Now we do the integration by parts. This is the product rule backwards. So can you remember the product rule? Let's have a look. I've got y equals some function u times another function v. Here's how you differentiate it. You take the function u and you multiply it by the derivative of v. That's what v dashed means, the derivative of v. Then you add v, the function v, times the derivative of u. It's as simple as that. That's how we did the product rule differentiation. Now we are going to be integrating to go backwards on the product rule. So let's see what we do. Remember, u here is a function of x, u function of x, v is a function, they're both functions of x. Let's integrate this statement here. D by dx of uv equals uv dash plus vu dash. Let's integrate that here. And I've written it in this line over here. The integral of that piece there is written here. And the integral of this uv dashed is written over here. And the integral of vu dashed is written over here. You should be happy with that. Right, now integration will undo differentiation, but won't undo all of these here. If I undo d by dx of uv, there's no problem there. I just get uv, because that's just the derivative of the whole of uv. Here I've got bits and pieces. I've got u times the derivative of v dashed. So if I integrate that, I'm not just going to get uv dashed. So I'm just going to write there the integral of uv dashed. And the same goes with this one, the integral of u dashed v. Right. So what can we do with this? Well, we'll make either this one or that one the subject of the formula. I've made this one here, uv dash, the subject of the formula, and I've taken this one across the other side and get minus u dashed v. So there's my formula there. The integral of uv dashed equals uv minus the integral of u dashed v. Let's just put the tick there. That line there is going to be the formula I use. Notice I'm still integrating on the right-hand side, but I'm hoping that this integral here on the right side is easier than the one on the left side. That is the key to this whole thing. Okay, let's take an example. The integral of x cos 5x. Our approach is normally to always use the polynomial x or x squared or x cubed always to be the function u. There is an exception when we've got ln x involved. We'll see that later. But let's just let x equals u, and cos 5x will be v dashed. All right. Now let's do the work on the right-hand side here. If u is equal to x, u dashed is equal to 1. Okay. And if v dashed is equal to cos 5x, I've got to find v. How do I find v from v dashed? I must integrate. So the integral of cos 5x is sine 5x, and then divide by the derivative of 5x, which is 5, and I get a fifth sine 5x. All right. Why have I done that? Well, because look what we've got here. We've got uv dashed here, but in the formula I need v, so I had to find v. And I also needed u dashed in the formula, so that's why I had to find u dashed. Now I'm just going to plug this formula in over here. Let's go. What's u? Here it is over here. U is x. There it is there. What's v? Well, v is 1/5 sine 5x, straight substitution. And just check that the rest of the substitution is correct as well. Minus the integral of u dash, which is 1, that came from there. And again, v repeated, 1/5 sine 5x. Now this line here, which I'll put a green tick on, hopefully this is an easier integral than before. Well, it certainly is. For a start, it's got no more x's in it. Let's just clean it up. I've got minus 1/5 sine 5x. Okay, the integral of sine 5x is minus cos 5x. Now don't forget you've got to divide by 5. So if I divide by 5, it's going to affect this 5 here, and you're going to get 1/25. Okay, 1/5 times 1/5 is 1/25. Then that minus and the minus is going to be a plus, and that's how I landed up with a plus 1/25 cos 5x there. And you can check that the rest of that is correct. Here's my answer here in that square bracket. I'm going to differentiate it to check that I get back to what I started. Okay, so let's differentiate 1/5 x sine 5x. I need to use the product rule on that. So I notice that I've got 1/5 here. Let's take that out. There's the 1/5. All right. Then I've got x times the derivative of sine 5x. That's 5 cos 5x. Sine 5x times the derivative of 5x, which is 5. All right, and then I've got to go sine 5x multiplied by the derivative of x, which is 1. And there's that, sine 5x times the derivative of x, which is 1. That's fine. Now this piece here, I'm going to do in the second bracket. Okay, 1/25 I can put on the outside. The derivative of cos 5x is minus 5 sine 5x. The derivative, not the integral, remember. So the derivative of cos is minus sine, but it's got 5x, so I differentiate the 5x and multiply by 5. Remove those brackets, check what happens. These two terms will cancel out, and you'll get x cos 5x just as we expected, which was the integral we were required to find. Okay? Right, the second example, and you'll see that I've got ln x involved. So straight away, this is the exception. You let that be u, and let the x squared be v dashed. All right, always let x squared be u, unless you've got ln x involved. Check that all of these on the right-hand side here are correct. Okay, then come back to me. Okay, well, derivative of ln x is 1/x, and the integral of x squared is x cubed upon 3. I hope you didn't differentiate there. The rest is substitution. There's the formula, uv minus the integral of u dashed v. Very easy to substitute. You've just got to transpose those formulas across. So do that for me. Okay, so check that that line there is correct. There's u, there's v, minus the integral of u dash, which is 1/x, and there's v repeated. V will always be repeated. There and there. Now, before we move on, we want to cancel this down. What do we get? Yep, x cubed divided by x is x squared. So I'll get x squared over 3 there. I've taken the 3 out, the 1/3 out, and there's the x squared. Okay, this just comes straight down here. And the integral of x squared is x cubed over 3. So there I've got the x cubed upon 3 there. Don't forget to divide by 3, right? And there's the 1/3 in front. That gives you a 1/9. So everything's the same. This term is that term, which is this term. And the integral is easier. There it is there. 1/9 x cubed. The whole thing explodes into an easy question. Hope you're happy with that. Right, now you do the differentiation of this answer and check that you get back to what you started with. I've done it just below, and you can check that I've done it correctly. All right? Right, sometimes we need to integrate by parts twice in a question. For example, here I've got t squared. Notice I've changed the variable here. We're dealing with t's here, so I'm integrating with respect to t. That's just good practice for us. Everything's done on the right-hand side. You know that you're going to let u be equal to the t squared, and v dashed will be e to the 3t, unless we're involved with ln. All right, derivative of t squared, easy, 2t. Derivative of e to the 3t, 1/3 e to the 3t. There's your formula, uv minus the integral of u dashed v. Check that all the substitution is correct. Up to here, this line, end of this line, everything is easy so far. Check that it's correct, that all the substitution is correct. All right, let's see what happens now. Over here, this integral in there, I need to clean it up. And you'll get this step over here. You'll notice what I've done. I've got that 3 going under the 2. Take out the 2/3. Then I've got t and just the e to the 3t. Just look at that integral there. You notice we've still got a t left. It's easier than what I had. I had a t squared before, but I'm not finished yet. So let's go with u and v's again. I could use capital u's and v's or f's and g's. I've just stuck with u and v. Let the t be u, let the e to the 3t be v dashed. Same thing happens again. You need to find u and v. There, I've done it there for you. Check that I've done it right. Okay, now I'm going to go back here. This integral here that I'm talking about here, that's the subject of the formula. Here it is. I'm going to continue along that line there. Here we go. So 1/3 t squared e to the 3t, that's that written down over there. Minus, here's the 2/3. Notice I'm going to open up a big square bracket for that integral. There it is. There's the 2/3. There's my uv dashed minus my u dashed v. That's all going to replace that piece there. Okay, now there it is. All that line there is the new uv minus u dashed v. Check that I've substituted correctly. All right, then that integral has to be done. All right, let's clean this up. This piece here appears there. What about this piece? There's 2/3. Let's check that. 2/3 times t, that's no problem. 2/3 times t times 1/3 gives you 2/9 times e to the 3t. There's that 2/9 t e to the 3t. Now, I'm going to take this minus 2/3 and I'm going to multiply it by that minus 1/3 there. That's going to give me plus 2/9. Then I still have to integrate, don't forget, e to the 3t. So I've written there integral of e to the 3t. I haven't done it yet. We'll do it on the next step. So everything appears the next step. Here I go. The integral of 2/9 times this is e to the 3t 1/3. So I get 2/9 times 1/3 e to the 3t. Everything else stays the same. Let's sort that out. That's 2/27 e to the 3t. And you see, you can leave it all like this if you want to, or you can take out e to the 3t, factorize it. We take that out. That's what you're left with over there, and the whole thing is ready and finished. Right. Right, now we're going to do integration by parts for definite integrals. All you have to do is attach the limits. So here I've got integral of uv dashed. Notice I've got these limits a and b written on. Same formula, uv minus the integral of u dashed v, but I've put the limits on that there, on the uv, a and b, and I'm going to substitute them into there. And I've got the a and b, I've got to integrate this as a definite integral. Okay, example. Let's take a look at this one. The integral of x sine 2x. Obviously, the x is going to be u. There it is. U dashed is 1. V dashed will be sine 2x. There it is. The integral of that, which is v, is minus a half cos 2x. Okay, I'm ready to substitute in the formula. Here I go. The formula is uv. So you need to write uv there. There's ux, so it appears over there. And there's v, minus a half cos 2x. There it appears there. Take away the integral of u dashed, which is 1. So there's the 1 here. I've got a 1 written in there somewhere, believe me or not. And the v is the minus a half cos 2x. So all you'll see there's the minus a half cos 2x, which if you multiply by 1 is simply that. All right, let's just clean up this integral before we go any further. So I'm going to do this integral, which I've ticked in green there. The integral of that of cos 2x is a half sine 2x. But don't forget to multiply it by this half here, and minus is a plus. So I get plus a quarter sine 2x. Okay, but we can sort that out just now. All right, there's my limits, 0 and pi upon 2. You know that if you're doing integration, you've got to be, and you want to substitute angles, they've got to be in radians. So that's why these angles are in radians. So firstly, I'm going to substitute that pi upon 2 into the formula. So I'll get minus a half pi upon 2. There it is, minus a half pi upon 2. Cos 2 times pi upon 2. 2 times pi upon 2 is pi. So that's that bit there. Subtract 0 substituting to there gives you 0. So this whole term will be 0. That's how I got that. In a similar way, I'm going to substitute the pi upon 2 into the sine 2x. 2 times pi upon 2 is pi. So I've got a half times a half is a quarter. I've got a quarter sine pi. And then I've got a half times a half is a quarter sine of 0 when I put the 0 in. And I'm going to subtract that piece there. Now you should know that sine of 0 is 0. So that piece is 0, no problem. This here is minus a half. Cos pi is minus 1. Cos pi is minus 1. So I've got pi upon 2 times minus a half is minus pi upon 4. Multiply that by minus 1, you get plus pi upon 4. That's the answer for that one. And of course, when you put the 0 into there, you're going to get minus a half times the 0, and that gives you 0. Okay. Okay, now try this last example here and then come back to me for a quick chat. All right, I hope you let u equals x plus 5, because then u dashed is 1. Got it there. And then v dashed is cos x, so that v is sin x. Straight away, there's the formula. There's the u and the v there. Okay, x plus 5 sin x. And I'll put the limits of integration on. Take away the integral of u dashed v. There's u dashed, which is 1. Okay, the 1. And there's the v repeated sin x. You'll always, as I said, have that v repeated on the right-hand side like that. All right. Okay, rest of it's now easy enough. X plus 5 sine 5x, that just stays exactly the same as the above line. The integral of minus sine x is cos x. Okay, minus, you get sine, and the limits are pi upon 2 and 0. Okay. Over here, I've written pi. I should have written pi upon 2, and I should have written pi upon 2 over there. So you can change that for me. Thank you very much, because it should be pi upon 2. So please change that. All right, let's put pi upon 2 there. I get pi upon 2 plus 5. There it is there. And I get sine pi upon 2 there. There's the sine pi upon 2. Okay. Then I've got to subtract 0 substituted in. So I get 0 plus 5, which is 5. And I get sine naught, and sine naught's naught. So that piece there is naught. Cos pi upon 2, there it is there. That's naught. And then take away cos naught, and that's 1. Cos naught is 1, but I've got a minus sign in the front of it. So remove these brackets. I've got pi upon 2 plus 5. And don't forget to take away 1. So I've got cos. I've got pi upon 2 plus 4. That's my final answer. I hope everything's all right there. See you in the next lesson.